All right, so let's go ahead and get started. As I said, my name is Mike, and this is a webinar from ORS on simple digital paleontology. So let's see, was that the first slide? So just by way of introduction, my background is as an imaging scientist. I came to use software such as Dragonfly through my needs from transmission electron microscopy in biology research. But I've been supporting users in image processing and data analysis and visualization for a little over 15 years now. So I've been very lucky enough to see a lot of applications from a lot of different disciplines. So hopefully if you have any questions, I'll be able to address them even if they're outside of my domain of expertise. A company I work for is called Object Research Systems. We're a small software company headquartered in Montreal. We've been in business for almost 13 years now. We have software applications in both the medical space and non-medical research space. We have registered users from over 80 countries. We're a very disciplined company. Our medical product required us to meet a number of bureaucratic requirements, regulatory agency requirements. So we've got very standard and strict compliance. All right. So the two products that we have in our portfolio is a clinical product called ORS Visual, and then another product called Dragonfly. And Dragonfly is our product for non-clinical academic research or even industrial production. And Dragonfly is the product we're going to talk about today. So let's just make sure. Yes, very good. So Dragonfly is a product that is basically serves these needs for academic research scientists and production engineers: a platform for 3D visualization, for performing measurements, inspection, for doing image processing, whether it's smoothing images or denoising them, or trying to enhance edges, or trying to adjust the contrast in such a way, usually to advance the goal of image segmentation. And image segmentation, of course, being the objective of being able to label the different constituent materials and phases in your image for some substream analysis and sort of quantitative analysis. The product also has all the capabilities you need for animation, so you can make movies that really tell stories about the science that's being revealed by your data. And we'll get into some of that as well today. So just the final slide about our product. We used to have a product called Visual SI for scientific investigation. We took a lot of time and refactored that software application with a lot of end goals in mind, and we put so much effort into it that when we went from version 1.8 of the software to 2.0, we renamed it. So 2.0 is the first launch of Dragonfly, and that came out in September. Because we retooled everything, we used a unique architecture that gives us the ability to do rapid feature development and maintenance, and allows us to debug and advance our application very quickly. So our next release, 2.1, is coming out in April. It includes some very substantive changes, including a macro engine that allows users to capture and repeat repetitive tasks and apply them to other applications. It also includes a machine learning segmentation tool. We'll be doing another webinar on that coming up very soon. So we have a very short production cycle. Every 4 to 6 months, we're able to make a new minor release. We'll have 2.2 coming in the fall, which will have a number of new features as well. We'll also be launching our first beta release on Linux and probably also Mac with that 2.2 release. So our core technology really enables us to move very quickly and generate really terrific features for our users. Part of that is we're built on something called Anaconda Python, which is a useful toolkit for developers who want to do scientific computing. This allows us to do things very quickly, but it also allows users to make extensions and add-ons. You can see from our rendering today that we have a state-of-the-art image, high-impact rendering engine. We also have some state-of-the-art image segmentation, which seems to be useful across applications across all domains. There are a number of features that we give access to the users that we produce in the factory, but we also have features that end users can develop and add on and make their own extensions. We'll be launching an app store this spring, which will allow users, once they've customized their color lookup tables, or they've written new image filters, or maybe they've written useful macros they want to share with the community, or they've gone all out and written complete feature-rich GUI plugins that they want to share with the community. any sort of plugin that fits into these sockets, which we can talk about offline if you have questions, will be possible to share through the store, so users will be able to download and then use them for themselves or make revisions. One final note before we start the demo. So we have a number of flexible licensing options for various institutional needs for our commercial customers, but I think most of the community in the audience for this topic, for paleontology, you're probably coming from museums or coming from academic posts, in which case, if you're coming from one of the qualified countries, then you'll qualify for free licensing for non-commercial use. So we're happy to take questions on that at the end as well. So that's a little bit about Dragonfly. Let's go ahead and get started with some demonstrations so you can see how the application behaves. And we'll probably finish up within about 25 or 30 minutes from now. So maybe about 10 or 15 after the hour we'll be done. We can take some questions. Maybe we may even finish ahead of time. So what you're looking at is the user interface of what Dragonfly 2.0 looks like right after you launch it. It may look a little different for some users. A lot of what you see can be configured in user preferences. But by and large, what you'll see is you'll see control panels on the left and on the top that allow you to interact with your scene. In the middle, you'll see have an area for viewing your scene, and there can be various layouts for how you have views arranged in that scene. And on the right, you'll have a list of all of the data objects you've loaded. Those could be images you've loaded. Those could be segmentations you've performed or measurements you've performed, as well as any images you derived during your session. So this is kind of your workspace, your My Document space. When you first launch, you're prompted, unless you override this in preferences, you're prompted with an Import Datasets dialog that allows you to navigate the file system and choose some files that you want to load. What I'm going to do is I'm just going to choose one of the recent files I have loaded, and let's start with this one for now. When I load a data set, after I choose one, I have some very convenient properties. So if I know that the pixel size is encoded wrong in the image, I could override it. So I could say, well, I think this is a 5 by 5 by 5 micron pixel image, for example. Over here on the right side of the screen, you'll have some useful information. For example, this total image is about 800 megabytes. If you want to, at this point, if you wanted to, for example, crop the image, maybe you don't want to load the entire image, then you could set some crop parameters in X and Y. So this gives a very convenient way of restricting what you're opening at launch time. And you can scroll in X and Y, but you can also scroll in Z. So maybe if I wanted to only load slices 200 to 300, I could define that in the user interface as well. So you could set some crop parameters like this, and then you see I've reduced my footprint from 800 megabytes to 15 megabytes. But let's just load the full data. I hit Reset Crop. There are other features in here as well. For example, this is going to be some mouse bone with titanium implant, so I could write a name that's going to show up in my project space. So anyway, this is about the behavior of the image loader, but we don't need to dwell anymore on that. Once you've, oh, and by the way, I'll mention, some of you may be collecting data on CT scanners, those, for example, medical CT scanners, which encode the data directly in DICOM format. I do want to tell you that in 2.0, DICOM format is not supported, but in 2.1, which is launching in April, and we already have available in beta now, DICOM import is supported. So if you have need for that, just let me know. We can hook you up with a beta if that's required. So once you load a data set, you may have an environment that looks a little bit like this. Over on the right, you see I have a data set listed, and I can click off of it, or I can click on that object in the list, and then I see its attributes. So here's a snapshot of this particular data set. It tells me that it's 780 or 770 by 770 by 770 pixels. Gives me a little bit of information. Tells me about my color mapping on 2D views and my 3D rendering settings. You'll also note that whichever image I have selected here, I see its window leveling attributes up here. In fact, let's go ahead and get started with some of these user control panels. What I'll first draw your attention to is that the individual control panels you see can be collapsed or minimized to make advantage of your screen real estate. Not only that, but if you want to undock a control panel, you can just drag it away and have it somewhere else on the screen. If you want to dock it somewhere else, for example, on the top panel or the right panel or back on the left panel, then you can just position it there and double click and it's docked again. Now, When we first load a data set, ordinarily what we want to begin doing is adjusting the brightness and contrast of the image. And so I want to draw your attention to the window leveling widget. So the window leveling widget is where we control the brightness and contrast. If you look, what you're seeing here is a histogram of the 3D data set. So this has probably a peak out here for some black pixels on the edge, and then a bunch of low dark gray pixels, and then some high intensity white pixels that spread out. And this is on a logarithmic plot. We can see if we take it on a linear plot that really most of the pixels in this data set are occupying this very small band right here. Now the way we adjust brightness and contrast, there are a number of ways of accessing it, but basically you're adjusting how the color lookup table that you're using is being mapped onto this histogram. So in fact, I'm going to change a preference here. I have a preferences in colors, and what I'm going to do right now, you see this sort of orangish color. I'm just going to scroll down to histograms, and let's make the background a light gray, and make the bins blue, and that'll be just fine. So what you can do on these histograms is you can map the intensity. So what I have is over here, you can see a grayscale color map. The grayscale color map is saying that everything on this edge of the histogram will be mapped as black, everything on this edge of the histogram will be mapped as white, everything on the interval will be some sort of gray, everything to the right of this is white, everything to the left of this is black. So you're able to see exactly how you're mapping that intensity space. Now, besides doing that, you can use what we call our window leveling mode. And for example, if I click on this button, I'll be in that window leveling state, which means a vertical drag is brightness and a horizontal drag is contrast. So you can adjust both at the same time. So you can map back and forth using either this widget or this widget. And you can reset it anytime you want as well. The brightness and contrast is one of those behaviors that's accessible many places in the application. For example, these amber text that you see on the screen are called text presenters, and they're interactive. For example, you see one marked slice. Yeah, I can drag on that and scroll through the slices in my data set. But the one marked W and C for window and contrast allows me, if I'm in my standard state, allows me to drag that and adjust the brightness and contrast without even having to be in any of these other states. So a number of ways of adjusting the brightness and contrast. I want to draw your attention to one final way, and that is the area tool. The area tool allows you to draw an area and tell Dragonfly you want to optimize the contrast for what's in that area. So for example, now I have a wide variety of contrast. If I'm interested, for example, this is a data set of bone with a titanium implant. If I'm interested in the bone contrast, I might increase the contrast here. Now this is all flooded, but now I can see the details of the bone, whereas before the details of the bone may have been lost. If I were interested in the structure of the noise outside, I could drag an area like that. So there are a number of ways of adjusting that. This mode is the most generic, and for most users, there is a mouse shortcut that allows you to access vertical drags and horizontal drags just by holding down, for example, I'm holding down the control key and dragging on the right mouse. Okay, let me load a more relevant data set for a paleontology audience, and we'll move forward. So let's, the data set I'm loading now is a CT scan and reconstruction of a Moloch, the thorny devil. This data was collected and archived at the Digimorph online repository maintained at University of Texas by Tim Rowe and colleagues there. So what I have now, so now I've got a specimen. Now this has not only the bones but also the soft tissue intact. What we see at initially, unless you've overridden your preferences, is a single view in the layout. If I want multiple views, I can click on one of these other layouts, and now you see I've got 3 planar cross-sectional views, where before I had just one. And in addition to these 3 views, I also have a 3D rendering. Now I can adjust the brightness and contrast in any of my views, and you'll see that in the 2D cross-sectional views, the brightness and contrast is synchronized. So here we have a data set, and we can start to inspect it in 3D. After you've optimized the brightness and contrast to the way you want, you may want to move on to some of the other tools for exploring. You may also want to adjust the lookup table. So I mentioned before that we've got a grayscale lookup table, and the lookup table can be modulated for the 2D views and independently modulated for the 3D views. So if I come over here into 3D settings with my Moloch selected, I could choose one of these other color lookup tables. So I could choose this temp lookup table that gives me some color and some variation. Now, in addition, you can modulate your 3D rendering with some lighting options. For example, we saw a widget, a control panel over here called Scene View Properties. It has a number of tools over here. There are a number of options over here. You see some advanced options called Shading Properties and Gradient Mode. Turns out that there are a lot of parameters to adjust between this panel and this panel. So we have some presets that adjust a number of those parameters at the same time. So you can see you can get some different renderings this way. So if I take this rendering, now we have a lighting model, and that lighting model allows me to do shadowing if that's what I'm interested in. So I can position the light source. So there are a number of ways of getting a quality rendering, and you can also adjust the opacity over here in the 3D control panel. So there are a number of ways of working in that respect. I'll go back to this view for now. So we see that we've got some bony tissue and we've got some soft tissue on the surface. And we see how this color map is now mapped to the intensity histogram. So we've got a lot of feedback in the user interface. Now, I've got one 3D view and three 2D views. With a specimen such as this, it's pretty obvious where these different views apply in 3D space, but sometimes it can be difficult to assess that. So we have a nice module called Visual Plane that allows you to turn on the view that you see here and have it rendered in the 3D window. So here I've got this view at the top right, has this little red flag at the top, and that is indicated here with the checkbox that says top right view with the red text. So now this view, which you see right here, is now rendered on 3D, in the 3D view. So you can roam around in 3D space, and now you know exactly where this slice is coming from. So you could do that for different views. You could also, once you choose this view, you could tell it to not show the data, but just show the position. So you have some other attributes. You could tell it to do some clipping. So now if I have a 3D rendering with some solid rendering, and I want to apply a clip plane, I can do it that way. Now, these views which you see are right now all orthogonal, but it's very easy to make them oblique. So right now, for example, you can see that the red plane is at an angle, a right angle with the blue plane, and the blue plane is at a right angle with the green plane. So if we turned on all three of these, you would see how they're all orthogonal. But if we wanted to adjust the angle of the plane, it's quite easy. So I could take this and just simply make it oblique. Or if I wanted to make it double oblique, I could do this. So for example, if I wanted a sagittal section of this specimen, I could take this blue plane and turn it on. And now I could again turn on clipping. And you can see that the data here is rendered. If you wanted to make it transparent, you could adjust the brightness and contrast of the 2D view, and now you have a transparent view. It shows just the high density opaque region. So with that blue view, now I could tip it and try and make it a more perfect sagittal section. I can adjust where it is in the 3D view by dragging like this. Also, if you're working in the 3D view, you could just select it and click Show Handle, and now you have a handle in the 3D. One of the things I don't think I've mentioned yet is that any one of these views you can double-click on the screen to make it full screen. So you might be working in the 3D screen and not have the 2D views accessible, and that's a case where you might want to do dragging. So you can tip the oblique plane with the tip of this ball just like you could tip it over here. I'll go ahead and turn off my views. Let's put on another view. We'll bring up the opacity and turn on a light source. So that's a little bit about rendering. That gives you some introduction to the 3D window, the 2D views, the window leveling widget, and the visual plane. You also have these views. So, for example, if you're interested in let's adjust this just a little bit. If you're interested in mapping this view so it looks like what you see on the screen, you can also apply the flip rotate panel. So I could rotate it. Oops, I wanted to select this one. I could rotate it 90 degrees. Or I could rotate it in small increments. You can also do horizontal flips and vertical flips as such. So it's very easy to control the orientation of what you're looking at. At any point, you could also reset all of that on the main manipulate panel. It's a reset, which effectively resets the brightness and contrast and the orientations of all the planes you're working with. Okay, so that gives you some instruction to those panels. Now I want to call your attention, this flip rotate, you may have noticed that these buttons are blue, and some of these buttons over here, for example, are gray. When I was going through the orientation, I told you that on the left and on the top you have control panels. On the right, you've got your data and settings, and in the middle you've got your view. At the bottom, you have a status bar that tells you what state you're in the application. The application is always in one state. So right now I'm in track state, which means I can move the mouse to track around in my 3D view. I could also be in pan state, or I could be in zoom state. But I can only be in one state at a time. You can temporarily enter another state. So for example, even though I'm in track state, I may have a mouse key that allows me to pan in the image or zoom without actually changing. So temporarily changes and then comes back. But the point is, I'm only in one state at a time, and the state buttons are indicated in gray. When I apply an action button, they are in blue. So the action buttons may apply like a vertical flip, or horizontal flip, but when I apply those flips, I'm still in the track state. So now you see the blue buttons affect an action, but they don't change the state you're in. So if you want to change the state, those are modulated by the gray buttons. All right, so let's move along. Now, all we've done so far is visualization. If you're interested in making measurements or annotations, you can look at the annotate panel. So you may have a ruler and you may measure the distance from one object in the view to another object in the view. Now you'll see over in your data properties and settings, you'll have ruler objects. The currently selected ruler is being rendered in red. If I select nothing, then neither of them is rendered in red. And those colors are all modulated in preferences as well. If I select on one of the rulers, then now I can see its attributes. I can see its on-screen thickness. I can also see its linear length. If I'm interested in looking at the image intensity, the line profile under this ruler, I can select the ruler and then ask for a profile intensity, and we can see exactly how the image intensity varies along the length of that. If we've got multiple images loaded, then we can measure the intensity on multiple images simultaneously under the ruler. Now, one of the things I'll mention at this point is if you go to another view, then you won't see that ruler. So I'm using a mouse wheel to go to other views. And maybe that ruler, you can't remember what slice it was on, or maybe it was on an oblique angle that's hard to get back. You can always right-click on the ruler and say, look at this annotation, and it takes you right back to the view where you can see that annotation. So the annotations include rulers and angles. You can also draw regions and interrogate the histogram of intensities underneath, etc. Okay, now let's change gears for a minute and talk about segmentation briefly. So segmentation is the ability to label pixels with what they are in the data set. So maybe you might want to label individual bones, or maybe you want to label something, you maybe want to label the appendages or label the head, etc. You can use segmentation for that. Everything we've done so far has been over here on the main tab, but I'm going to switch now to the segment tab. So the segment tab normally has two panels, one called ROI Tools and one called ROI Painter. I've moved my ROI Painter to the top. So ROI Tools allows you to define regions of interest for labeling your specimen. So for example, if I wanted to label the bones in the specimen, I might create a new ROI, give it a color, and give it a name, call it bones or skeletal system. And now over here I have a segmentation, what we call a region of interest for bone. At this point it's empty, there's nothing in it, but it's where all of my bone segmentation will be encoded. So you can work on the 2D views. In fact, in 2.1 you can work directly on the 3D views, but again 2.1 doesn't launch for another couple of months. And you can work on your segmentation directly in these views. Now the segmentation tools allow you to label certain pixels. So for example, if I were interested in labeling some of these pixels, I could do something like this and paint the pixels of interest. Now that would be painstaking and it would take forever. So instead, you can use tools such as the Define Range tool. This allows you to modulate what you're painting based on the intensity in the image. So for example, I can set the intensity of the bones, and now I could, with the define range checked, I could come up with my paintbrush, and I'm even going to use a 3D paintbrush. So now I'm using a sphere instead of a circle. And if I go through a few slices, you see that there are multiple slices that are being painted and rendered. So now I'm painting a few select pixels and regions in this image. Now if we pop back to the 3D window, what I'm going to do here is put this back in grayscale, and just by switching the 3D lookup table, whoops, not inverted, I want standard grayscale. And what I'll do is I will turn on the 3D rendering for the bones, and what we can do here is we can see what has been segmented. So if I select my initial data set, I see its attributes. If I select the bones region of interest, I see its attributes. I'm going to collapse some of these. Here's the total volume of what I've segmented, and here's the density attributes on this image, the minimum intensity, maximum intensity, etc. But down here I have some attributes that affect how this segmentation is rendered in the 2D window. So in the 2D window I can make that a very bright yellow or a more faded yellow. Let's turn this off for now. But in the 3D window I also have some options. So what I can do is I can adjust how intense or bright that those bones are labeled, but I can also fade away the data set. So what this allows me to do is look just at what's been segmented. Now I have the option of doing this the inverse as well. So I can bring this back if I want to emphasize the segments, if I can have it at a higher opacity, and of course I can have a little bit of color highlight if I want. But I can also suppress the data that I've segmented by dragging the ROI down and keeping the data set high. And so now you're able to repress that's been segmented. Now maybe there are some bright pixels that are on the edge that didn't quite get encapsulated in my segmentation. Well, that's easy enough. I could just select my 3D bones ROI, and I could just tell it to do some dilations in 3D space. And by growing it in 3D space, now I've made it a little bit bigger, and so you can see that those surrounding pixels are now also encoded with that segmentation. So the segmentation allows you to label bones for analysis. It allows you to label bones for rendering and for understanding what you're looking at. Let's see, what was I going to show next? I think what I'll do is I'll show you another way of using the ROIs that's not for analysis, but just for visualization. Let me explain. So I've created one ROI called bones. Now I'm going to turn off the 3D rendering of it. I'm going to create a new ROI, and I'm going to call this Cutaway. And I'm going to use the Cutaway for a rendering trick. So what I'm going to do here is I'm going to come along the spine, and I'm going to, on Cutaway, paint a 3D sphere. So I'm using the mouse wheel to change the paintbrush size here. So if I do something like this, now I have a sphere that I've created. If I were to render it in 3D, then you can see exactly where that sphere is. What I'm going to do is, on this, we saw that we can adjust the 3D rendering. So what I'll do is I'll turn down the opacity, and if I turn down the ROI but leave data set up, now you can see that we now have a cutaway inside the object to reveal what's inside. So you could do this very easily and create some novel 3D renderings. I should mention also one of the panels we haven't looked at yet is a panel called Move, and this allows you to modulate whatever is selected. So if this ROI, this region of interest, happens to be selected, then I can translate this, and now I have my 3D rendering looking somewhere else. I have my cutaway modulating another region in the data set. So that gives you a powerful way of using the segmentations, not just for labeling pixels, but for creating novel 3D presentations of the data. Okay, I think what I'll do now is switch over to another data set and maybe show a couple of these features again. So let's do new session, and that's going to clear all my workspace and effectively restart the software so I could choose another recent data set. So what I'll do in this case, I'll look at another data set from the Digimorph collection. Let's see if I have there's the Moloch and there's the alligator. Let's see if here I've got a cheetah skull, and I'll load this data up very quickly. So suppose I were interested in labeling the teeth. Now, I'll go again to a 3D rendering. If I'm interested in segmenting some of the teeth in this data, then I might position, so here, for example, is, sorry, not the red slice, but this green slice. It's positioned right here. Now I might tip that slice so I can get a plane that cuts right through the middle of some of the teeth that I want to segment. Let's go a little bit higher than that. Now, just very quickly, I'll show you the point I want to make, which is the ability to separate different labels for subsequent analysis. So what I'm going to do here is we'll just pop open this plane and we'll very quickly create a new region of interest, which we'll just call teeth for now. And we will use the define range again. We'll try and get the teeth without getting too much jaw. And so we'll choose a setting something like this. And we're not going to spend, an hour getting a good segmentation. We're just going to go through and get a few teeth on a few slices so we can show you what there is to see in this demonstration. So we may use a bigger paintbrush, go up and down a few slices until I have something interesting. Now again, I can come over here and I could modulate the 3D opacity of my teeth. So teeth selected in 3D rendering. Oh, we do have to turn on the 3D rendering. And so it looks like I got a bit of jaw in there, but that's okay. So if we turn region of interest on and data set down, then we can see these teeth. Now what I'll do here is I'll take this data set and I'll tell it to do advanced analysis, which is going to separate the individual renderings, separate the individual labels. So what it's done here, it's not going to be clear at first, is it's identified all the separate segmentations that it found. Now, if these are all connected, then it'll just be one lump segmentation. And then if you have a few isolated pixels, they'll be separated out individually. What I can do here is I have a table that gives me a list of all the separated segmentations, but also a histogram. So if I look at the histogram by volume, then I can very quickly weed out the low volume. I apologize for the colors here. Someone has adjusted my preferences. But I can very quickly weed out the low volume from this table and delete it from this analysis. Now what I have are the 6 biggest components in my segmentation, and I can sort them by, if I go back to the table, I can sort them by either volume or by their label intensity here. Let's click on all. So I have the 6 that are left, so I can sort them by volume and then give them a color map. And then I'll go ahead and turn on the 3D rendering. So here you can see the individual colors of the different bone, or in this case, jaw connected to teeth. So if you wanted to spend time doing the segmentation, you could render all of the teeth and then clean it up and then separate the teeth. And now you could, in this same table, you could compute attributes and properties of those teeth. So you could compute the volume of every tooth and the surface area of every tooth, as well as the position, the centroid coordinate of every pixel. Okay, so I think I'll load one more data set, and then maybe we'll stop and take questions. What I wanted to show you today is that it's very easy. The software interface is very intuitive. You can watch the videos and learn, and once you practice once or twice, you can become quite productive in making 3D renderings and making segmentations. You can also make movies. I should do that before we take questions. So let's do this data set. Let's do this one here. So this is a proto-turtle from the Permian. This data comes to us from Tyler Larson, who's now at the Denver Museum of Nature and Science. This is a sample that shows now we've got a fossil that's still embedded in rock, and we can try and get a 3D rendering that gives us some good contrast. But you can see that the bone is still in rock, and so if you wanted to do the segmentation, this allows you to do, effectively you're doing your virtual excavation directly inside the 3D data. So it's very easy to set the plane you want. So for example, if I wanted to tip this plane here in this view, but also tip it in this view, And then now in this view, you can see that I can scroll through and get a very easy orientation for doing my segmentation. So I could pop this screen open, and we could rotate it a little bit, and we could proceed with doing some segmentation here. Now, I'm not going to do any segmentation on this data set. I think we've already seen enough about that. But I guess I should show you very briefly how the movie tools and animation work. In the 3D view, you can right-click and choose Open Movie Maker. And what it does is it gives you the movie editor, which is a timeline of frames. So, for example, if I were interested in seeing the data from this view, but then maybe I wanted to adjust the window and level and zoom in and turn the rotation, then I could right-click and say Add a new snapshot keyframe. And now we have two keyframes, and they are just linearly interpolated. So it's very easy to build up a storyline like this. Your storyline can also involve rotation. So, for example, if I had this, I could, from this view, and you can double-click to restore view, you can right-click and add another keyframe. Now, these two are the same. If I click in between, I can tell it to add a rotation. So if I tell it to add a rotation to the right, then, and you can drag the keyframes to adjust the timing on the timeline. So now here we go here, and then we spin it around to the right after we reach it. So you can very quickly tune the segmentation you want, and anytime you want to adjust it, you can just double-click on it and adjust the properties of that keyframe, and then tell it to right-click or tell it to update the keyframe with your new attributes. You could also use your visual planes and clipping planes and adjust those at different positions in the timeline, so that you can use cutaways to reveal. If you had a segmentation and you wanted to fade away all of the data set but leave the region of interest shown or increase the opacity of the region of interest, you would again just create keyframes and adjust the attributes to keyframes so that that would all be encoded in the movie. When you're not using the Movie Maker, you can just right-click and close Movie Maker, and now we're back to our normal productivity interface. So I think that's where we'll stop today, and I'm going to go ahead and open the floor to questions. So if you have any questions, just fire away. You can either text the question in the chat window, or you can unmute your microphone and ask a question, and I'll take questions. But I do want to thank you for your time and attention. Hopefully you've seen how Dragonfly can be a very productive and useful way for getting your digital paleontology program moving forward. So, any questions?
Can you hear me?
I can hear you now.
Okay, good. This is Norm McLeod in London. What Windows version are you running, or what Windows version is best to run your software in?
Right, so we run on Windows 7, Windows 8, Windows Vista, and Windows 10. Are those all real versions? We run on Windows 7 and up. I happen to be running on Windows 10 right now. We only build for 64-bit, but that's because we have absolutely no demand from any of our customer base. None of our customer base is working with any 3D data, seems to be working on 32-bit platforms. So any Windows 64-bit from Windows 7 and up is fine. So
Windows 7 and up. Okay, and what about emulation? Has anyone reported problems? I work on a Mac, and apparently you don't have a Mac version of the software released yet. So does the software work under Windows emulation?
It's going to depend on the Mac. I don't know if you're working from a laptop or a Power Mac or our Mac Pro.
It's a MacBook.
A MacBook, you say?
Yeah.
The 3D performance is of course dependent on the hardware, particularly the GPU. The MacBooks have been updating their GPUs over the life course of that product, but they've usually been tailored for Photoshop and image editing applications rather than 3D performance, because Apple, as a strategic decision, has not been going aggressively after gaming and 3D scientific applications. So the performance is usually not very high. I guess the bottom line is I don't have any evidence to report. It's going to be something you're going to have to try, and we'd love to have your feedback. I will mention that the last time I was exploring Mac for applications like this, and I was using Parallels, the Parallels and some of the other virtual machines restricted how much of the graphics memory the guest operating system was able to use. So if you're only able to access 500 megs of your 4 gigs of video memory, then you were really hamstringing what you could accomplish. So because of that, if you were going to work on the Mac hardware, you would be better off rebooting in Boot Camp. But I know that's a headache, and you're no longer taking advantage of your Mac operating system. So we don't have a really good answer for that. So I guess it's just going to be, I'd love to hear your results, and we could share them and post them in the forums, but that's not something we've done any internal testing on, so I really don't have anything I can tell you.
I'm going to have to upgrade the Windows emulation software, not upgrade it, but change versions, because I've been running in a very low version since, because last time I used Windows, that's what I was used to, so I'll upgrade that to Windows 8 or 10 or whatever, and then I can report it back to you. The one last question: the rulers that you were using, is that are those distances exportable?
Yes, I believe so. I think we can export them as an XML. That used to be the case, and then that XML was, easily processed and interpreted text file. So if I right-click and choose export data to file, you can export it actually as a CSV. I'm not sure. I think that will probably export the XYZ coordinates of each endpoint of the ruler, maybe also the length, but all of that would be sufficient.
Oh, okay. Yeah, I'd prefer using the points rather than lengths, because lengths are easy to calculate from points, and usually these days we don't mess with lengths. We don't use lengths anyway.
Right. I've got a couple of questions in the chat window. Let me get to. So the first question from Devin is: does Dragonfly have options for landmark placement and analysis? So 2.0 does not actually have landmarks. 2.1 introduces some new tools to the Annotate panel, one of which is a point recording tool, which allows you to add an arbitrary number of three-dimensional points, which can be viewed in the 2D screen or in the 3D screen. I think you can actually add them in the 2D window or the 3D window. So if you want to try the beta version, I can get that to you, and then you can export that. We know there are a lot of applications in comparative anatomy where you may want to do landmark analysis. If that's something you're interested in, I'd like to have some feedback from you, because that's something that would be very easy for us to add a plugin or support a user who wants to add a plugin for making that application accessible, where maybe you have templates or libraries of landmarks and you want to place the reference landmarks on your experimental specimen so that you can do your morphometric analysis downstream. We don't have anything like that, but it would be very trivial for us to extend that. So if that's something that interests you, please send me an email offline, and we'll continue that discussion.
I would suggest you do that, because that was essentially the question I was asking before about the rulers, as to whether you could fake the landmarks.
Right. So we already have that in 2.1. It's just what you want to do with that next. We'd like to support the workflow rather than you having to work around it. We don't want you to use Dragonfly tools to pigeonhole them into your application. We'd like to be able to support your application in a user-friendly way. The next question we got was from Andrew: can Dragonfly export and import 3D files to and from other applications? What file types are acceptable? So in 2.0, you can import TIFFs, you can import JPEGs and PNGs. You can import any raw file, so as long as you know the data type. Is it encoded as an 8-bit, or is it encoded as a 16-bit unsigned integer? And the dimensions, is it 1,000 by 1,000 by 1,000 or something else? So raw type is very easy to import. With 2.1, we add DICOM import. We also we did a modification of the image reader, and so now you can write Python code to write a new image reader. And so we use that to write an image reader for a VISO file format. We also have imports of volume graphics. Both the first, there are two different formats for volume graphics that we know about, and we're supporting both of them now. And it also means, I showed you in the beginning, you could crop data on import. Even when you write your own Python extension for an image reader, that gets supported out of the box. So but we've never written export for those formats, so we don't export to a Visa or VG Studio. We could document the process so you could see how to write your own export. It would probably take anyone who knows any Python a little more than one afternoon to write an image export module in a standard, reasonable file format. And then that could be part of either part of the product, or you could share it through our app store, and that goes online. So that allows you that's for image import and image export. Something I didn't even think to show today is if you do a segmentation, you can create a surface object. So not an image object, but a surface object can also be created. And from the surface object, you can create an STL file. So if you want to do 3D printing or some surface or shape analysis. So let's go back to the, well, I'll just do the Mohawk, for example. So if I do segmentation, so I showed you how I could segment with the paintbrush with the use range selected, but I could also just use that use range just to do straight thresholding. So here I am, I just loaded data, I go over to define range, and I select the intensity associated with bone. Maybe I look at the histogram to see if there's anything in here that's going to give me any clues. And now I could just click add to new, and now I've taken all the intensities associated with that interval range, and I've labeled them green. So if I turn on a 3D rendering, then we can see, here's my skeleton. Now, this object in the segment tab, you'll see there's an option to export to mesh. So I'm going to tell it to export to a normal mesh. This makes now a surface mesh. So it's important to distinguish between 3D images and surface meshes. So the surface mesh is basically a collection of triangles that describe a surface, whereas your 3D image data set is a matrix of pixels. With this surface, this collection of triangles can be rendered and inspected. So let's turn off everything except a mesh rendering. So you know, if you zoom in really, really closely, you'll see individual triangles. So I think even in this view, we could tell it, let's show the rendering as a wireframe, and now you can see this is just a collection of triangles if you zoom in high enough. So this object inside the user interface, you see I've got my image, my segmentation, and now a mesh. This mesh can be exported, and if you choose export mesh to a file, now you have options such as STL, VRML, VTK, etc. So that may not have been a question you were asking, but just to be thorough, I wanted to explain that yes, you can import images, you can export images in very few formats, but you can also create meshes and then export the mesh. Okay.
I think that was the question he was asking. So, but thank you.
Okay, great. Of course. Great. All right. So I think that catches up on the questions in the chat window. Any other questions before we call it a wrap? Well, thank you for your attention today. If you haven't already downloaded Dragonfly, it's free to download and install on a Windows computer, and you can get started using it right away. It comes with a 30-day license key. If you want to continue using it, our non-commercial licensing program just requires that you send us a copy of your institutional ID from your institutional address, and then also fill out a user survey. You fill it out once a year, and it just tells us what you're doing. You know, are you trying to make movies of fossils? Are you trying to do comparative vertebrate anatomy? So your application, what software you've used in the past, and a little bit about the computing platform you use, so we can understand, are most of our users using high-budget computing platforms, or most of our users, trying to use budget computers with less powerful graphics cards, so we have a better understanding. So that user survey is really helpful to us. But once you give us the photo ID and complete the user survey, if you're from, there are a few countries which we can't support because of licensing restrictions, but most of the countries in the world we're able to support. We can grant you the license for 1 year, and then if you come back within a year and fill out the survey again, then we just extend the license every year that way. So thank you for your attention today. I'll be capturing this video and putting it online later for streaming for users that might, if you want to share it with others. But thank you for your attention, and have a good day, and let us know your thoughts on Dragonfly, or if you have other questions, just reach out by email. So thank you, everyone, for attending today.